Hello everyone. This video is in continuation with the previous one where we started with hydrocarbons. We had discussed preparation of alkenes. Now in the present video I will cover physical and chemical properties of alkenes. My more stress will be on chemical properties. Physical properties only in very short I will take. Physical properties of alkenes that there mainly we are going to discuss. You need to learn about the physical state of the existence, then you need to learn about their boiling point, what trend they will follow for the boiling point, and their solubility. So I will be talking mainly for the boiling point and solubility. If you consider alkanes, they have the electronegativity of carbon and hydrogen atom very close, and because of this, as there is not appreciable electronegativity difference, they are non-polar. And being non-polar, the kind of interactive forces which these alkane have is only the weak van der Waals forces. Or if you will recall about this, it's the dispersion force or the London force which you might have learned in the gaseous states of matter. Yeah, so the alkanes, they have dispersion or the London forces in them which are very weak, and as they are very weak, their boiling points are low. Now, because of the low boiling point, most of the alkanes, especially if you consider the alkane still carbon atom 4 butane, till that it is in gaseous state, then the next few members will be in the liquid state and higher ones are in solid. So what actually happens when the number of carbon increases in alkanes, or say their molecular mass increases, the strength of or value of their interactive forces, that is van der Waals force or the dispersion force, that also increase, because that is actually dependent on the surface area. And when the molecule is having more and more carbon atoms, obviously the surface area will increase, and that will cause the van der Waals force to increase, that will cause the boiling point also to increase. So alkanes, they have low boiling point as they are non-polar, but with increase in the number of carbon atom, boiling point increases. Then a very interesting point is observed in the boiling points of isomeric alkanes. And the concept on which we are going to discuss this, that is going to remain the same for alkenes, even for alkynes. Not only this, the concept is going to remain there in grade 12 also, where you will be discussing about the boiling point of isomeric alkyl halides, then alcohols and all. So, like suppose if we take isomeric alkanes, for example, the isomers of pentane, normal pentane, isopentane, and neopentane. What actually happens here with increase in the branching, you will find that the boiling point decrease. And the reason behind this particular decrease in the boiling point is that with increase in the branching, the molecule takes shape of the sphere. And when molecules take the shape of the sphere, children, you can apply the mathematic concept here that sphere, they have lesser surface area. So because of that, when the surface area decreases, again the van der Waals force will be decreasing, and when van der Waals force decreases, then boiling point will decrease. So this is the reason, and very important. Again, you can have 1 mark type of the questions based on this. You may be given few compounds of alkene or altogether of alkene, alkene and alkynes all together, and you will be asked to arrange those compounds in the increasing or decreasing order of boiling points. So I recommend, there are lots of question banks available in the market, and these days many of the question banks are available on telegrams also, so you can go for the question bank, find such questions where the alkenes, alkene or alkynes and all together of them are asked to be arranged in increasing or decreasing order. Do practice them. This will give you the more and more clarity on the concept while solving such questions, and definitely you will be able to crack such questions in the examination. So now let's start with the chemical properties. Alkanes being the saturated one, the most common reactions which these alkanes give is substitution reaction. And the substitution reaction is nothing. Substitution reaction is in alkanes one or more hydrogen can be replaced by another atom or say another functional group. So whenever such reaction occurs where hydrogen are getting replaced by any other atom or group of atoms, we call that substitution reaction. And in substitution reaction, the first one which is there in your syllabus is halogenation. So let's discuss halogenation reaction of alkanes. In halogenation, the reaction is very simple. I will write the general reaction first. The reaction is like alkanes on reaction with halogen. The reaction condition may differ with different halogen atoms. First of all, we will not be talking about the fluorination in this. Fluorination we don't talk because fluorine being highly reactive, the reaction is very violent and it is not able to control such violent reactions. So we will not be talking about the fluorination. Then coming to chlorination, bromination and iodination. Chlorination and bromination that can occur in the presence of sunlight or upon heating above around 500 degrees Celsius. And iodination, the reactivity or say especially the rate of reaction for iodination is very slow. Reaction is reversible there, and to obtain iodoalkane in more and more yield, we have to use some oxidizing agent. So soon you will get, I'm writing reactions for all such like methane on reaction with chlorine in presence of sunlight. For sunlight you can write H nu, the basic concept. Energy of sunlight or energy of electromagnetic radiation written as H nu, and these are in the gaseous state. You will get methyl chloride and hydrogen chloride gas. Methyl chloride and hydrogen chloride gas. So the reaction seems to be very simple. One hydrogen from methane is getting replaced by chlorine. However, the actual scenario is a little different. If the chlorine is present in excess in this reaction, it takes a chain reaction. One by one, all hydrogen will be getting replaced. So the chain reaction you can write like this: methane on reaction with chlorine in presence of sunlight will be eliminating HCl and forming CH3Cl. Same way, again on reaction with chlorine in presence of sunlight, eliminating HCl and forming CH2Cl2. Again one hydrogen got replaced by chlorine. Same way, again on reaction with another chlorine molecule in presence of sunlight, loses HCl or say HCl eliminated, and one hydrogen gets replaced by chlorine. Just a minute. And again on reaction with chlorine molecule in the reacting mixture, HCl gets eliminated and it gives CCl4, carbon tetrachloride. Then bromination can also take place in the presence of sunlight. Similar reaction will be taking place. Especially for iodination, you need to keep in mind that this iodination reaction is reversible and very slow. It is giving methyl iodide and hydrogen iodide. So reaction is reversible and it is very slow. So when the reaction is reversible and slow, you are going to get this methyl iodide in very less amount. But suppose if you want to increase this methyl iodide, what you can do, you will be using oxidizing agent like nitric acid or hydrogen iodide. This two oxidizing agent can be used in this particular reaction. When these are used, what they do, they oxidizes hydrogen iodide formed in the reaction to iodine. And children, when this hydrogen iodide will be getting oxidized to iodine, you can apply Le Chatelier's principle of the equilibrium here. Iodine, the amount of iodine when increases, then the forward reaction will be favored, and the forward reaction when favored, it will be giving more and more amount of methyl iodide. So this is how you can explain this. Again, important for examination, especially about this iodination part. It's actually very hidden kind of part, you can say. Uh, Definitely questions are important from this. This is going to come in grade 12 also. Grade 12 also, the same thing is there. Iodination, the same discussion is there. And for both the years, I am saying this is important part. This may come in the examination. That's why iodination of this being carried out in presence of oxidizing agent. So you must be very clear with what this oxidizing agent does to the hydrogen iodide formed in the reaction. And you can try writing the reaction of hydrogen iodide with nitric acid or hydrogen iodide, any one of the oxidizing agent. Okay. Now talking about the mechanism of this reaction, as I said that this is a chain reaction. Here actually the reaction proceeds by a free radical formation. So let's see how this reaction proceeds. Although the mechanism for this part, previous year it was deleted, this year it is not clearly mentioned. They have not, CBSE has not given any deleted portion very clear. It is what only they have given the term 2 curriculum or term 1 curriculum. In term 2 curriculum description, the topic is not listed. Halogenation mechanism is not listed. So maybe it might be deleted, but because of being it's very unclear, let's try to understand the mechanism. Although mechanism everywhere where it is there in your syllabus, where there is it is the part of your portion, you must go for it, because mechanism gives more insight into the reaction and you will be more clear about the topic. So let's see mechanism of chlorination reaction. So mechanism of chlorination, this is actually a free radical reaction. So there are three steps in this mechanism: initiation, propagation and termination. Let's first see the step 1, initiation. In initiation step, you need to understand that these chlorine molecule in presence of sunlight. So chlorine in presence of sunlight undergoes homolytic fission. Now homolytic fission, children, you need to know here that in homolytic fission, what they do, they take away their shared electron. You know very well that in this covalent bond, each of the chlorine atom has contributed one electron each. So when this homolytic fission occurs, they will be taking back their electron which they have contributed for sharing. And this way, now each of the chlorine atom is going to have one unpaired electron. They are going to have one unpaired electron. So this is how chlorine free radical is generated, and this is the initiation step. Then next step is propagation. In propagation step, this chlorine free radical is going to cause homolytic fission in methane molecule. Let us write methane molecule this way. This is methane molecule, and chlorine free radical is causing homolytic fission in this. So that homolytic fission can be shown here this way. Here in this bond you can consider the homolytic fission taking place. So that will cause the electron being withdrawn here. Hydrogen free radical joins with chlorine free radical to give HCl, and you get methyl free radical here. So methyl free radical, unpaired electron on carbon, and this hydrogen and chlorine free radical join to form HCl. This is your propagation step. Further, this methyl free radical can join with another chlorine molecule which is there available in the reacting mixture, and on reacting with this another chlorine molecule, it will cause this chlorine molecule to undergo homolysis. So again, a chlorine free radical which is generated here joins with methyl free radical to give CH3Cl, and in addition to that you get one chlorine free radical. Further, you can show this step to be in continuation. Methyl chloride again on chlorine free radical reaction generates this free radical and HCl. Same way you can show the cleavage. If you want to show the cleavage here, you can write this molecule like here. You can show like this, and then you can show the homolysis occurring here. So this homolysis cause again to generate CH2Cl free radical, and the hydrogen free radical which is formed here that joins with chlorine free radical to give HCl. Okay. So this free radical which is formed here further will react with a chlorine molecule in the reacting mixture, and again that will induce a homolytic fission in this, and the chlorine free radical formed will join with CH2Cl free radical to form CH2Cl2, and left will be one chlorine free radical. After this comes termination step, and this will continue. I have shown propagation, and that I have shown 2 steps till the formation of CH2Cl2. Now the same way you can proceed further. Again, if this can undergo homolytic fission of the carbon hydrogen bond, so we'll be giving CHCl2 free radical, and the same way you can extend this step. This is what we call propagation. Termination is the step where all the free radicals must be getting used up. And what are all possibilities in which free radicals get used up? So a chlorine free radical may join with another chlorine free radical, giving Cl2 molecule. Methyl free radical formed in the propagation first step may join with chlorine free radical, giving CH3Cl. Or you may have methyl free radical joining with another methyl free radical, forming ethane also. Okay. So termination step is the one where all free radicals get used up. This what explains mechanism for chlorination reaction. And the other halogenation reactions like bromination and iodination will also be following the same kind of mechanism for this reaction. This is free radical chain reaction. Okay, so this is about the first reaction. Now we will be covering more reactions of the alkanes. So after halogenation reaction, now next is the combustion reaction. Combustion reaction of alkanes are the most common reactions, children. Every day you are observing this reaction. In your kitchen, if you will stand near your gas stove, there actually the combustion going on is of butane. Same way, think about combustion of CNG. It has methane gas in it. The major constituent of CNG is methane. Same way, kerosene, petrol, these all contains alkane only, and they are undergoing combustion reaction. So the combustion reaction of alkene, the general reaction for that can be written like CnH2n plus 2 plus 3n plus 1 by 2 O2. this will be taking this much mole of oxygen and will be giving n number of CO2 plus n plus 1 H2O. And yes, of course, energy will be given off. This is combustion reaction, and you know very well in all combustion reactions, energy is given off. So you can try writing the reactions for this. Take different values of n. Start from methane, n is equal to 1. Especially for methane you write, for butane you take n is equal to 4 and you try to write the reaction. This kind of question can be given in examination for 1 mark. When it comes to reactions, then I will say all reactions are important. You cannot skip any reaction in that. But for this combustion reaction, one thing again I will bring into your notice, that every day which the combustion which you perform or which you observe in your kitchen, that is giving you a non-luminous flame, that is the bluish flame is non-luminous, and there it is showing complete combustion. Whereas other possibilities also, it can undergo incomplete combustion also, and incomplete combustion, children, I won't be repeating here. Incomplete combustion somewhere you might have learnt in very lower grades like grade 8 or 7, there you might have learnt. So only thing is the incomplete combustion will be giving you. So only thing is, children, incomplete combustion is going to give you luminous flame. That means wherever you are able to see a yellow flame, a luminous flame, the incomplete combustion takes place, like the candle flame you can say, or flame of a kerosene lamp. Okay. Now the next in the sequence is controlled oxidation. Controlled oxidation is the oxidation of alkanes which takes place in presence of some specific catalyst, and these examples will also give you idea about the specificity of catalyst. You will understand about specificity of catalyst also, that how specific they are for a particular reaction. A catalyst used with a particular substrate and the reagent in a reaction gives some specific product, and then when the catalyst changes, the product formed in the reaction also change. So I will be talking about this controlled oxidation. So in the controlled oxidation, now let us see all possibilities. You will get to understand about specificity of catalyst also. So methane, when oxidized in presence of copper as the catalyst, temperature is 523 Kelvin and carried out at 100 atmospheric pressure. There, methane get oxidized into methanol. Methanol is formed as the product. You can do the needful for balancing this equation. Same way, methane can get oxidized even in presence of molybdenum oxide as a catalyst. And in presence of molybdenum oxide catalyst, it oxidizes as methanol and water. Now see the difference. Here you will get clarity about specificity of catalyst. The copper catalyst is specific for giving methanol as the product. Substrate and the reagent are the same. It is giving methanol as the product when copper is used as catalyst. Whereas when catalyst changes, you can see the product also has changed. Now methanol and water is getting formed as the product. So this is called that it is said that catalysts are very specific for a particular reaction. Okay, this is known as specificity of catalyst. Then comes ethane. Ethane, when oxidized in presence of manganese acetate catalyst. In presence of manganese acetate catalyst, when this methane is oxidized, that will be giving you ethanoic acid as the product and water. And in many cases actually these alkanes, they resist oxidation. But whenever an alkane is having um, like hydrogen atom which is bonded to tertiary carbon, like as in this case, this is, identify the IUPAC name of this first. This is 2,2-dimethyl propane, and so this one is 2-methyl propane, and you can see hydrogen atom available here on the tertiary carbon. So when this is oxidized by alkaline potassium permanganate, alkaline potassium permanganate, this compound will be giving tertiary alcohol. This is how oxidation takes place. This is 2-methyl propane, and this one is 2-methyl propane 2, the IPAC. So this is about controlled oxidation. Now let's go for the next reaction. So next reaction of alkane is isomerization reaction. Let's see what is this isomerization reaction. Isomerization reaction is such a reaction in which normal alkane is the one where all carbon atoms of it is in the straight chain. So normal alkene when heated in presence of anhydrous aluminum chloride and hydrogen chloride gas, that undergoes branching, and it leads to the formation of isomers of the same alkane. So that's why it is known as isomerization reaction. Like one example I can give here, normal hexane, CH3, CH2, 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 and again CH3. This is normal hexane. You can see all 6 carbon atoms are in the straight chain. So this normal hexane when heated in presence of anhydrous aluminum chloride and HCl, hydrogen chloride gas. This is going to give you the isomers of the compound, and the isomers of the compound are like this. It is going to give 2-methyl pentane and 3-methyl pentane. These two possibilities are there: 2-methyl pentane or 3-methyl pentane. Okay, so the reaction is very simple to understand. Isomerization is taking place as isomers are obtained in the reaction. After this isomerization, the next reaction in the queue is aromatization reaction. For this aromatization reaction, you will have to keep in mind that the reaction is possible only when the alkane is having 6 or more carbon atoms. So when alkane is having 6 or more carbon atoms, that undergoes cyclization and dehydrogenation when heated in presence of catalysts like chromic oxide or molybdenum oxide or vanadium pentoxide. If I write reaction for it, the reaction is like, first I can show this alkene with 6 carbon atom, normal hexane only. This compound is normal hexane. And why I have written like this, it has a reason that soon you will understand. I have written it like this, and now I am hitting this over the catalyst like molybdenum oxide or say chromic oxide or say vanadium pentoxide. So when it is heated over any of these catalysts, this undergoes cyclization. So when cyclization occurs, it is very easy to understand here that a six-membered ring will get formed. Here cyclization will occur. First, hydrogen getting removed from both the carbon and cyclization occur. So there you get CH2, CH2, CH2 at all positions. But it will not stop here. Then dehydrogenation occurs, and dehydrogenation is leading to the formation of double bond between adjacent carbon atoms. So this is how you are getting aromatic hydrocarbon here. This is the simplest aromatic hydrocarbon, benzene. And as this reaction is leading to the formation of an aromatic hydrocarbon, that's why the reaction is known as aromatization reaction. Okay, so now let's see the next reaction. Next reaction is a reaction of alkane with steam, and we have another reaction as pyrolysis in the case. So the next reaction of alkane is reaction of alkane with steam. Let's say this reaction. However, this reaction I feel is quite familiar to you. A reaction with steam, somewhere you have learnt in hydrogen chapter in term 1. And the reaction is like uh, alkane when heated with steam at a very high temperature around 1273 Kelvin, that gives carbon monoxide and hydrogen as the product. Like if I write this reaction for methane, so methane when heated with steam in presence of, actually nickel is used as the catalyst here, and the temperature is 1273 Kelvin. So this reaction gives carbon monoxide and hydrogen as the product. Okay. If you can recall about this mixture of the product, they are also known as water gas, and this reaction was also given some name in the hydrogen chapter. You just go through that chapter once again and find out what name was assigned to this reaction, and then you can comment for your answer in the comment section. Then next comes after this is pyrolysis reaction. Pyrolysis is also known as thermal cracking. So pyrolysis or thermal cracking. Pyrolysis or thermal cracking of alkene. I'm not going to write equation for this reaction, only you need to understand that alkanes, when they are heated at a very high temperature, at a very elevated temperatures, like at temperatures near around 773 Kelvin, or in some cases even beyond those temperatures, what happens? Many carbon-carbon bond cleaves. Not only carbon hydrogen bond also cleaves. So it mainly involves cleavage of carbon carbon and the carbon hydrogen bonds, and that is why it gives mixture of hydrocarbon as the product, which can be alkane, smaller alkane, lower alkanes, or can be alkene or the alkynes also. Okay, so you just need to practice for this reaction. There is nothing like any big concept involved in this. Cleavage of carbon carbon and the carbon hydrogen bond occurs, gives mixture of alkane, alkene, and sometimes alkene with alkynes also as a product. So that's it, children. Here we have covered 10 chemical properties of alkenes, and now it's around 1 a.m. of the, say, 27th February. Uh, Children, yes, I got some request. I tried to work on that request. Tomorrow also, say today also, I will be working 27th of Feb. I will be working to fulfill your demand, your request. But only one point I have to say here at the end of this video, that when I had made the effort, same way you also put your efforts. Organic chemistry is not going to then trouble you. ये जो खौफ मचा रखा है ऑर्गेनिक केमिस्ट्री में, this is not going to be continued in your life then. Just make the effort. At the beginning itself, I said it's the writing practice which is very much required in organic section. So put your efforts, give lot of writing practice to it. And at some places where I have shown mechanism part, I have shown some specific way of writing the reactions. Try to follow in the same way, and definitely you will get this. So yes, today in the next video we'll try to cover alkenes, alkynes, and we'll see for aromatic hydrocarbons as well. Or at least I will try to cover up all important topics, as I am aware of your examinations coming at the beginning of March itself. So you don't have much time left, but still, let us give a try. Hope this video will benefit you. If it is benefiting you children, only one request: do like it, pass it on to more and more number of students in your family, in your friend circle, and subscribe the channel. Make this journey a successful one. Yeah, all the best children.